So yeah, looking at it's the PID provider, and I can do a.out, and I can dump out all the symbol information.
Right. So here's an invocation using the PID provider. PID provider followed immediately by the PID of the process of interest. In this particular case, I wanted to see what libc routines that particular process was calling. So I left the function field blank, and I'm just going to do a simple count aggregation. And I think that was this bash shell here. So I'll just bash away at it for a second, and then now I have a list of all the libc functions that bash shell called. So not a modified bash shell, just DTrace through its probes in there, and I can do finer grained profiling from there on, pretty much anything.
I think it's also responsible for us to note that while we can look inside binaries, not all software companies like you doing that, and sometimes you'll sign terms and conditions of use to say that you're not allowed to de-engineer software. So obviously we can't encourage you to go and break those terms and conditions of use, and they're starting to become quite more common than they used to be. I do wonder if the word of DTrace is spreading out. But DTrace is a wonderful de-engineering tool because of the way it lets you see software in flight.
Interesting, yeah, just very quickly, I said I got in from Tel Aviv last night. I was working at a customer site, Migdal Insurance, that's running a software package from Software AG, Adabas, which is a database, and Natural, which is a programming language. And we wrote about 30 DTrace scripts to get inside the Adabas database software. And the Software AG folks were actually looking at the data we were collecting, which was we were actually capturing low-level commands to the database and profiling them and determining which files they were reading and writing. And they were just, how did you get that? Where did you get that? How did you do that? And they weren't, I couldn't tell if they were happy or unhappy about the fact that I was actually looking at their database with a tool that they'd never seen before in ways that they hadn't looked at it themselves. But I did it anyway because, well, I'm from New Jersey. Go ahead.
At risk of sounding like I don't understand a lot of this, which I freely admit that I don't, I'm at a customer site. I've got a process. It happens to be a WebLogic application. I can run a truss against the PID, and it gives me specific information related to that particular process. Is there a way, where I could run a DTrace command against that PID to give me a baseline of what that application's doing, so that then later on I can use maybe other DTrace scripts or whatever to check the behavior of this application, what it's actually doing, without having to go down the level you guys seem to be.
Yeah, so the question in the front was, I'm a DTrace novice, and I've used Trust before. We all know and love Trust. Probe effective Trust notwithstanding, it's very, very heavy duty. Don't trust DB Writer on a production Oracle database system. Yeah, I've done it too, Richard. So the question was around sort of baselining. I have a process. It was a WebLogic application. It could be any number of things. Is there a way I can use DTrace to sort of get a starting point, a rudimentary idea of what that process is doing? So I'll let Brendan answer it in a minute. My answer to that is I like to start with the provider in DTrace called the syscall provider when I start looking at that. Actually, the first thing I do, just to answer that, if I'm on Solaris, is I run prstat-lm. This is a DTrace BoF. I'll show you this for 30 seconds. This will give you the big picture view of what all your processes and threads are doing. So that's where I start. But getting back to DTrace, usually what I start with when I look at a process for the first time is the syscall provider. The syscall is a great place to start, because system calls, as you all know, are an application, calling into the kernel to do a privileged operation. And system calls are where applications meet the kernel. So it gives you a very, very good idea of which kernel subsystems the application is calling into, which gives you a very good idea of what the application is doing. Is it doing a lot of read and write system calls? Okay, so I'm doing a lot of reads and writes. I'm reading and writing files. Is it doing a lot of fork exec stuff or thread create stuff? So I'm creating processes or I'm creating threads. What is it actually doing? So the syscall provider is is my answer to your question as a great way to start looking at a system. And while I'm typing, I'll let Brendan provide his answer.
So my answer, and the question was, how do I baseline an application so that I know if it changes over time? I'd answer that by saying, how do I just take a general look at an application using DTrace? The two things I'm interested in are on CPU time and off CPU time. On CPU time is what code paths are running that are hot. Off CPU time is generally the I/O that it's doing. Off CPU time, Jim's already on the way to explain, you can do that with the syscall provider. It's actually pretty good at showing you why your application is taking time off CPU if it's doing system calls. For the on-CPU provider, if you Google DTrace one-liners, I've written it in a bunch of places, there's just a one-liner that will show you either the functions or the stacks that are hot on CPU. Very easy to use DTrace to collect. And so they'll give you an idea of what code paths are hot and why am I stepping off CPU. I gather them as text files if I'm looking at an application over time. This sometimes happens because the customer says, my application is bad at 2 p.m. or my application is bad in the morning. And I need to have a baseline of when it's normal to compare to when it's bad. Some of the things that just profiling hot CPU functions pick up, it actually picks up a heck of a lot more than you would realize. It will pick up mutex contention because that's hot CPU cycles. It will pick up different code paths if it's taking it for the issue. And the same for I/O. If it's changed its I/O pattern, you'll be able to spot the difference. So yeah, I'd answer that by collecting two things. Look at the DTrace one-liners for the hot CPU stacks, either kernel or user land. And also, as Jim's doing, you can use syscall to look at I/O, and you can also use the shed provider to look at when we step off CPU. That's pretty much the same thing.
Yeah. So this is the output from this is the output from this invocation, where I said I'm looking at all the system calls system-wide. I'm not interested in processes named DTrace, and I'm just going to say who executed and what system call did they execute. Now, if you have a particular process that you're honing in on, this is called a predicate in DTrace. It's a conditional statement that allows us to test for a specific condition we're interested in when the probe's fired. So we can say we're only interested in exec name equal Java, exec name equal HTTP, not equal to DTrace, what have you. So I can use a predicate, the predicate mechanism in DTrace, to filter the data such that I don't only see what I'm interested in in what I'm seeing. And then here, the output wrapped around on the screen, but I've got a couple JVMs that are doing some LWP system calls and doing some polling. My X server is doing a few things, and GNOME terminal's doing a few things. So I can get a big picture start there or hone in on a process. Going back to Brendan's suggestion, no, I didn't save that one, which is I can use DTrace and the sketch provider, if I can type and say, all right, every time I get on CPU, system-wide, who's getting on CPU, and where do they come from in their code? So every time a thread gets placed, excuse me, every time a thread gets placed on CPU, that probe's going to fire. I'm going to aggregate on the name of the process that was on CPU when the probe fired, and I'm going to grab a user stack. So now I have, any questions about that? No. Let me see if I can go up to something a little more. Okay, so here I can see, you know, when my X server got on CPU, it hit a poll system call through this user path. When DTrace got on CPU, it parked a thread using that code path. So I could see my on CPU code path, or going back to...
I really use the profile provided for that. On CPU is often just showing you why you left CPU.
Yeah, okay.
So I may have missaid when I said on CPU. I meant just profile on CPU to see what's actually hot using the profile provider.
Well, I'll use this one to show why we're going to sleep.
Sure, yep.
So this is actually one of my favorite one-liners because, as I said, performance work is all about chasing latency. And one of the reasons you get latency is because your workload threads go to sleep because they issued a blocking system call. They're doing a read or a write of something. Using the off CPU probe, and aggregating on exec name and use stack, you can get a system-wide picture, or again, you can hone in on a process of interest. You can actually see why different components of your workload or a particular process or thread of interest is going to sleep. And yeah, so you're right, Brendan, this is basically showing us why I'm going off CPU. Yep. Hey, I'm jet lagged, what can I say? So you can see why you're going off CPU. If you want to see how you're getting on CPU, you can use the profile provider. Say I'm only interested in...
spelling profile.
You spell it like that somewhere in Europe. New Jersey.
Did I see a hand come up while I was... No? All right, so I'm going to do the same thing again. I'm going to grab the exec name. I'm going to grab the user stack. I'm going to use a simple count aggregation. So the profile provider is a time-based provider. You know, the vast majority of probes and providers in DTrace are based on a particular area in the code. The profile provider is a time-based provider. You can specify a frequency that you want the probe to fire. This is a predicate that says, am I running in user mode versus in the kernel? If I'm running in user mode, I'm going to grab the name of the process and the stack. Okay, and once again, I can see, all right, so this is better. I think it's better. No, this is better. So now I can see what my processes were doing on CPU in that probe file. And I can see what my JVMs are doing. I can see what my X server was doing.
So many time functions. Like, I wonder why time is so slow these days. I see a lot of time functions.
Yeah, I do too.
Get time of day.
Update manager, what the devil, all this Python library stuff. I got to go talk to Bart. Actually, I have to talk to Bart about something else too.
Get through time. Yeah, if I was to guess what would be on CPU, it wouldn't be calling time. Because
No.
they should just be reading the high-res timestamps out of the CPU. There must be some extra overhead that means they...
This is something I've never seen before. How do you add on ACPI? I mean, we only had one occurrence of it, so, but you know. So you can glean a great deal, long answer to a good question, you can glean a great deal about what your system is doing with just a couple relatively simple DTrace one-liners. And then, you know, drill down from there based on interest, importance, knowledge, experience, whatever. Okay, where are we at time-wise? We have 10 minutes left. Anybody else with questions, comments, concerns?
Are there going to be probes in Oracle?
Ah, great question.
Don't look at me. I don't work for Oracle anymore.
I work for Oracle, and the answer is, I don't know. We're working on it, but it's not a committed project at this point.
You can still address it like any other application.
Well, so yeah. Ooh, all right. Let me get my delicate dancing shoes on. So yeah, you can certainly instrument Oracle with DTrace. At the end of the day, it's just another application. It's a big hairball of an application, but it's just another application. One of the problems you run into detracing Oracle is perfect statement Brendan made earlier. Oracle is one of those applications that is intentionally
Obfuscated.
Yeah.
Well, not intentionally. There's a sensible mapping. It looks intentionally obfuscated.
It looks that way. There is actually a rhyme and reason to the function names, but when you grab stack traces out of Oracle processes, it might as well be with rare exception. It's very hard to glean what it's doing. I mean, you sometimes see, you know, db log write or redo log sync or something like that, but more often than not,
it's PQXRZZ.
Yeah. So the Oracle engineers could look at it and know exactly what it is. So we're working on getting DTrace into the Oracle database. I think Brendan, did you do the MySQL probes?
I worked on the MySQL probes, but there's been a few different incarnations of it.
Okay.
The MySQL provider is pretty useful. So that lets you look at so some of the probes that we put in there include query start, query end, and that allows you to look at query time in MySQL down to nanoseconds, and I can look at the client detail, the query string. If you walk up to a MySQL database, you've got things like the MySQL slow query log, which has a 1-second granularity, whereas with DTrace, I can, in production, without stopping MySQL, I can go and fetch some nanosecond timestamps out of the query log. And also use MySQL to use DTrace to look through the internals, look at how the query cache is performing, look at how InnoDB is performing. I've been working with some MySQL performance people who get pretty good at looking at a query string and understanding why it takes certain amounts of time. But with DTrace, you can drill down and prove it and actually measure the latency where it is.
And that's actually a good segue into what may be a reasonable point to sort of wind down on that we didn't mention, is that even though we talked a lot about how you can use DTrace to look at uninstrumented code, there is a facility in DTrace for instrumenting code and inserting your own probes called USDT, or user statically defined probes. So if you're a developer and you own a piece of software and you'd like to be able to use DTrace more effectively, I don't want to necessarily say more effectively, but the advantage to putting your own probes in DTrace is, as a developer, you can insert probes and select which arguments you want to make available and what data you want to make available when those probes fire in a semantically meaningful way. So, for example, MySQL is a good example of that. The USDT probes in MySQL have probe names like transaction start, transaction stop. It's a logical thing you would want to analyze when you're looking at a database. You know, log write start, log write stop, that kind of thing. So as an application developer, you may opt to use the USDT facility of DTrace and insert your own probes in your code, decide what data, what arguments you want to make available when those probe fires, and thus people can use DTrace when they deploy your software more effectively to analyze your software should the need arise. Here's an example of Java 1.6, which now comes bundled with the hotspot provider. Hotspot followed by the PID of a particular Java process. Now, unfortunately, this is Java code, so, and I don't have C++ built on my laptop yet, so the function names are a little hard to read, but you can see you get a fairly extensive list of probes in Java. This made use of the USDT facility, I think.
Yeah.
To do hotspot.
There are some cool probes in there.
There are some cool, yeah.
Garbage collect begin and end.
Garbage collect begin and end. Let's see. These are wrapping monitor wait.
Thread start and stop. VM
thread start,
shutdown.
thread stop. Yeah. So using, if you're running Java applications and you've got Java 1.6, you can get some really useful information about where your JVMs are spending their time, making use of that provider. So that's USDT, and there's USDT probes in several other bits that we talk extensively or talk a lot about in the book. Any other questions? Anything else you'd like to see or discuss?
Can I just show the? Do
Yeah.
you have the book PDF for the network chapter?
I might be able to do.
You have it up on the screen just earlier. The same thing.
Oh,
So
that's what you want?
yeah,
Because I have some of the book scripts.
the PDF, because I want to look at the table.
Okay.
That'd be better, thanks. So we've talked a lot about going in with MDB and looking at functions. I do realize a lot of people like just running scripts, and while it's great that I can sit down and write these fantastic programs, I don't sit down and write software whenever I need software. If it already exists, I'll go and grab it and use it. It's more efficient for my time. I don't go and write write my browser as I use it. So a lot of people do like to go and find DTrace scripts and use them. How many people have used the DTrace toolkit, for example? Okay, so most people here. I wrote the DTrace toolkit a while ago, and I have done an update, and I do need to do another update. Based on, I've been doing performance consulting around APAC, and I tried to be as comprehensive as possible and provide scripts for all sorts of different areas. Working on the book was an opportunity to revisit that And as any software developer knows, when you go to do something the second time around, you realize you did make a bunch of mistakes, or you were blind to some areas that you should have paid more attention to. I think a good example of that is the network chapter. And if I bring up the table, this looks really strange.
Yeah, I don't know why it did look strange, and I don't know why it looked so strange.
Let me bring up the... wow. I think you've clicked on some different type of view here.
Some different what?
View, like it's a...
I could have done anything. I don't know what I did there.
Like this is really strange.
Yeah.
Oh,
Yeah, I screwed something up.
have a look at your view menu. Maybe there's something in there.
Okay. Fine.
No, you don't want some of these continues.
I don't know. You might be better off closing it and reopening it.
Yeah, let's open this in, like, let's not open that in, you just type open for the file, and it'll open it up in the standard viewer. It won't use Adobe. So with the DTrace book, there's about 70% of the scripts are new that are not in the DTrace toolkit, and it's because we started off by listing the topics that should be covered with DTrace, and stepping through them, we became aware of how many gaps there were. Which is what I'm trying to say, is there have been gaps. That's much better. And the best way to show this is my table. So this is just one of the chapters out of the book. This chapter is on network lower level protocols. And previously, what scripts would you, and all of these scripts, the source code and examples are in the book. Previously, what existed was TCP Snoop, that guy. UDP stat existed because it's based on the MIBs. That did not. ICMP because it was based on the MIBs. And that's about it. And the rest are new.
Yeah.
I mean, some of these were part of the TCP provider when I developed that, but these are not in the DTrace toolkit. Using the system call provider to look at the socket layer is something that I just hadn't done much at all, and it proved to be hugely useful. The system call provider is actually an unstable provider. System calls can change, and they have changed in different last versions only slightly. I know most people don't think of system calls as being stable, and they're almost stable, but there have been subtle changes, which get exposed by DTrace. Sockets, tracing how sockets are created from the system call layer, proved to be particularly useful for things like showing processes and hosts from the client, from the server, looking at connection durations, showing socket I/O by process and type, tracing connection and first byte latency at the socket layer, showing the top busiest sockets, and identifying socket errors. Really, really cool stuff. I don't know why I missed this before when I wrote the DTrace toolkit, but I completely missed it. And that's something I've now covered thoroughly, is getting a lot of value from the socket layer. And
You want to do more here?
yeah, go down. We've got IP,
Oh, sorry.
IP scripts, TCP scripts. Most of these are new.
TCP/IO.
TCP/IO just shows sends and receives with flag translation. That was, when I developed the TCP provider, that is based on that, but there are other examples that are not. And we've got UDP, ICMP, and if you keep going over to the next page, it probably keeps, and XDR, Ethernet. So that was just for one chapter, which is network low-level protocols. For each of the chapters, we've got disk, file systems, languages,
System
applications,
view,
databases, system
Give your
view.
memory, CPU, application, yeah, so.
We try to go through each.
So go ahead.
I'm not saying a DTrace toolkit is bad. It does have pretty good coverage, but we did discover a lot of gaps when we were going through the book. I do need to somehow roll out a DTrace toolkit version 2.0 after the book because it'll have all the new scripts in it. But in the meantime, as soon as it comes out in paper form, you will have the most up-to-date collection of scripts. And it's much more comprehensive than we've created before. And it's a really good demonstration and use of DTrace.
So on that note, we're out of time. We started a few minutes late, so I took those few minutes on the back end, but I want to let VJ come up and do his BoF. So if there's no other questions, thank you all for attending, and I hope to see some of you Friday at the DTrace tutorial. Thanks very much.